Hey guys, FX, you start this one. I'm the one who usually starts them.
What's the thing we always say when we start? Shek, what made you apply to this role today?
Sorry, what?
Yeah, we say
No, I mean, I didn't hear the question properly. What was
we
that?
say like what made you apply to this role today? We always say that like you came into like a job interview on the pod, and then you just basically just go along with the law. Yeah,
Oh, okay. Okay.
yeah. So what made you apply to this role today,
Why should we hire you?
and why should we
Yeah,
hire you?
good question. I was bored. I found two guys on Twitter and I DM'd them.
Okay, I mean fair enough. You don't really get a lot of gigs, so like I think that works. Okay, barely you can hit it off this time.
Yes. Hey guys, this is another episode of Devs at the Bar. Today we're here with Shek. He's a big OG. He's a mystery box for me because of this. Someone who's technical and also more on the startup side. So I'm very curious on how he managed to integrate everything together. So to start, I'm interested in how you started your journey. Like, how did you go from distributed systems, Solana, getting your own startup, then also like contributing with Superteam to like help other people with their own startup? Like, what was the journey like for you?
Like all great, I mean, all interesting journeys, right? For me, Twitter has been a great place to find interesting people and interesting things to do. Back in 2021, when Superteam was just starting, I happened to be at a place in my life where I had a ton of free time because the previous company that was I was working at for close to 10 years had just gotten acquired, and I was all of a sudden it created a ton of free time in my life. So in order to kill that time, and it was also around the time where I was thinking about what next, what should I pay attention to, all the things that I wanted to do earlier but I hadn't seriously paid attention to. So many different things came together, and also the timing being like it being the beginning of the peak for crypto in 2021. That's when I discovered Solana, and I begin by setting up a pseudonymous Twitter account, right? Like Shake is not my real name, that's a pseudonym, right? And what started out as like a Twitter account with barely any followers, with a cartoon PFP, and I see people doing things on Solana. I see Superteam, and I replied to one of their tweets where Akshay was talking about how Web2 engineers should get involved in Web3, right? And then this is probably an asymmetric opportunity in terms of what is possible. And yeah, that's the start of it, right? And one thing, I've always been the type of person where I let curiosity or whatever interests me kind of lead the path for me. So it ended up being a natural convergence for all the things that I was interested in. So it also happened at the right point in time where I had free time, right? So that was a lot more important, especially for folks who are in the later part of their career. I was already, when I discovered Solana, I was already late 20s. I was, I had just gotten engaged. So life is getting serious, right? At that point, where having some amount of free time and mind space to engage with new ideas is very important. So it only happened because I found it at the right time. The community kind of pulled the rest out of me, right? It's the when you go from when you go from the hustle and the high octane environment of a startup to a big corp, you kind of start missing the energy, and which the initial super team Discord kind of replaced, in the sense that it was a place where we're seeing so many young talented developers like trying to do things. So I naturally found myself filling up all the available free time helping those guys out. And next thing I know, I was deep, neck deep into the whole thing.
Yeah, super cool. You said 2021, but I think we all know that 2021 Solana wasn't really distinguished in terms of being the chain that was going to win. I mean, we were very much the underdog. So it's kind of like the question I want to ask is, what was kind of like your mindset or your heuristic back then? What were you optimizing for that allowed you to pick Solana and say, oh, okay, this is where I'm going to through like a huge chunk of my time and my career, just building for the next in the next few years. Because if you're watching and you really don't have context, 2021 Solana wasn't like now it wasn't like very clear that Solana was going to win. I think
Yeah.
2021, circa 2022, we were very much the underdogs to a large extent. VCs weren't even investing in Solana companies because they didn't really see a clear path. But
Yeah,
Shek,
that's
yeah, Shek was actually there during that time. So, like, you could just tell us, like, what was your mindset? What were you optimizing for that allowed you to set your eyes on something like Solana? And at a time where you wanted to get more serious, you just had to, like, back the company or back the whole
yeah.
community.
I think there are two answers to it. There's a human answer, and then there's an engineer answer. The human answer is like it's like the type of people that you surround yourself with and the community, right? At the end of the day, that's how humans make decisions. These are whether it is technically the most optimal way to do something or not, especially in a very very early days where you do not have clear demand. Thinking about optimal way to do anything is an optimal way to do your consensus or optimal way to do your transaction processing. All of that would have been they wouldn't have necessarily been like a strong pitch for someone to come build something. At the end of the day, the initial hook was the fact that there were other high energy people that are going to be around you, right?
Yeah.
And it's extremely important. It's like the community aspect of it is extremely important for people to gravitate towards something, right? Because at the end of the day, people like people, and
Yes.
that's what attracts them. We often see this all the time with you have the two comparable technologies, but then the one community is like much more welcoming. They are much more helpful. Those are people that you like hanging out with. You naturally find yourself gravitating towards them versus something else, even if it might be technically superior, right?
Yeah.
That is number one. Number two is, I do not mean to say this is not even entering the engineering aspect of Solana, right? But the more and more I started, reading about Solana and understanding the underlying architecture of how Solana does what it does, it made a ton of sense to me because a lot of this were pragmatic engineering versus things that were academic in nature, where you're kind of expected to take something like Cardano, for example, right? Like IOHK still produces some of the high octane research, some of the most rigorous research from any crypto lab, but at the same time, no one gives a shit about whatever they have built, right? There's this very very famous SKCD where people keep raving about Haskell, and then it is so awesome. Lazy evaluation is so awesome, and then someone tells them, yeah, it's so awesome because no one ever calls that function, right? Is that why? So
Yeah.
it's much more important that you have usage that justifies putting in all the effort behind the engineering.
Yeah, I feel like one of the hardest pills as engineers to swallow, especially for engineers that didn't really work with a lot of community customers, like people who were like internal teams. One of the hardest pills for them to swallow is that like it's not really about how cool or complex the solution is. It's just really about adoption. And then oftentimes when you think about it that way, you realize that it's always about the simplest solution. So what can get the customer or the user from A to B pretty quickly without all the nuance and complications that kind of like makes us feel happy about ourselves. So like I guess that's one of the things for me that I picked up during because unlike you, I wasn't really distinguished in 2021. I was still in school coming into Solana, and this was like kind of like my own first rodeo, and one of the things that I learned when I was here, especially I'm not trying to name any community, but like one thing is that like from previous communities, very technical devs can be like snobs. They can be snobbish, right? And you might want to hate them for it, but it's very easy for you yourself to get into that mindset if you think a certain type of way. If you just think that people want to hear about technical discussions and this your new way of doing things or this new hash function, like it's very easy for us to get intoxicated in our own juice, and then just coming back to reality and stepping back into reality is just what keeps all of us like kind of like the Solana community on what's actually important and what's not important. So like I guess that's something that kind of like, even though you are claiming to meet, you kind of like also are a torchbearer in that, like, you still set that standard. No matter how high you like. Because I remember say like Solana 21. Tolly was in the Discord, like really replying a lot of people, and that's kind of like the culture that I really like about Solana. There is no like bridge, like there's no bridge to be constructed between you and the founders, especially now. I know now the founders are like, they have a successful company, but back in the day when they were really at it, you could really reach out and just ask your questions, no matter how challenging they were. The founders would always find time in their own right to answer you. And that's something that I saw with Solana, especially for me, that was quite receptive and not as intimidating as the other ecosystem. Because I came in here with no mentors, with no way to do it. I was just interested in blockchains, and I figured out as I went. And then Solana was kind of like, Solana already had a compatible culture for someone like me, because when you talk to people, they just reply and they just follow you up and ask how you're doing, and how your journey is. Even if it's not really holding your hands and pointing you to the way, you don't want to let them down. Someone who has taken enough time out of their busy schedule to kind of like show you pointers, you don't want to let them down. You want to show them that their time investment was worth something. And that's something that I feel like Solana got right, that other communities just kind of like underestimate, right? I say underestimate because it's not that they can't do it, it's just that they don't think that is important enough to do. And that's also kind of like one of the
I mean,
things
at the
I
end of
see.
the day, it's an open source project, right? Like
Yeah,
open source projects
you know,
are vastly different from, corporate ecosystem or corporate developer communities. There is a world apart of difference, right? In an open source community, if you feel welcome, if you like the product that you're using,
yeah,
and you want to, if you see an opportunity to make something better, you're going to send a pull request. And then then you kind of start hanging out with other people who do the same thing, right? I think that's, and also in the case of Solana, you also have some kind of, especially with super teams, you have it happens in a much more grander and larger scale than typical open source communities. So that means that it's not just developers building stuff. You also have other researchers. For example, say a DeFi researcher who is very deep down into new ways to do prediction market, or new ways to do options, right? And there's also room for them to go deep into whatever fancies their interests, right? Or maybe the person might be might be someone who is interested in policy or legal as well, because at the end of the day, when you think about your vision of having permissionless labor and capital markets, it's not just an engineering feat that's going to achieve that. It's going to be a multidisciplinary effort towards realizing that specific version of the world. For example, one of the reasons why I found myself gravitating towards all of this idea was like back in 2016, I read this book called Sound Individual. It was a very, very impactful book in my life. So after reading that's also the first time I discovered, how I knew Bitcoin as an interesting way to solve the Byzantine generals problem, but in terms of what it could mean for the world, that's the first time I only realized it after reading that book. From that time to actually make the jump to working in the crypto industry took like there was a 4-year gestation period, right? So different people get activated at different point in time. It's what is more important is that they find their tribe, and they find a place for them to be productive doing this.
yeah. I mean, like, you guys already, like, this was speaking in hindsight, so you already won. Whatever ideas you guys were laying down 3 years ago worked out, and Solana is Solana today because of all of us, our individual contributions to the ecosystem. So, yeah, we'll get into it. I know you're kind of like a formal verification guy, so, like, I wanted to, like, use this as an opportunity to learn what exactly formal verification is. I don't know if my memory serves me correctly, but like I remember some time ago that there was like a bounty on Superteam. I think sometime last year. I don't know if you were the major.
Yeah, I was the one who put up
Yeah,
that bounty.
yeah.
It was
I think it was
late
about
last year
like
when
states.
Alpenglow had just come
Alpenglow,
out.
exactly, yeah. Alpenglow verification, like state right. So you could just help me explain, like what formal verification actually is and why developers should care about it.
Yeah, great question. Before I answer that, like, let me ask a different question, right? As a developer, why do you think you should care about testing your code? Why do you think you should care about defining your data, the model of your domain and the model of your state machine and its transitions clearly?
Okay. So I think for me,
and also like what does types in a programming language give you, right?
yeah. So I think for me, I'm going to answer the first question correct, like my first question first. So like for me, why we test, I think for me now, why I tested before has changed, but like so far in my developer experience. Like, but now why I test is oftentimes when you write code, you might not know, but you are actually writing code biasly. You're writing with biased experiences, biased expectations, biased outcomes, and it is very easy for you to miss the in-betweens that get you from code to desired outcome B, like code A to desired outcome B. And if you do not test, you ship that into production thinking that everything is working, but there are multiple edge cases you could have missed. And that, like, that's why I test, And in this case, I would also like to say that's why you peer review. Because there are a lot of gaps when, especially no matter how good you are going to have like some oversight, some gap that you're missing, and then you didn't just actually, because to get everything correct is to hold a state representation of every possible edge case in your head. And for the human brain, that's not, I'm not trying to say that's not possible. Some people do it, but like it's unnatural. The human brain is an abstraction machine, it's a state representation machine, and it is not really good to use the human brain in a state representation manner. I don't know if you get what I'm saying. It's supposed to be abstracted. So,
yeah. I
so,
see here when you're trying to,
yeah.
when you're programming is the the art and science of converting an intent or an idea into an abstract model, and then using that abstract model to accomplish what your intent, right?
Yeah, exactly.
So between the intent and the model and the actual execution, there is possibility for several gaps, and you build all of everything else is a tool in service of making sure that your intent, your model, and the actual execution are in line with each other. So there are multiple ways to do it, right? Some of these you get that some of the guarantees, for example, type system gives you compile time guarantees on certain things, right? And for things that you do not get compile time guarantees on, you kind of put them at the runtime. And in order to verify that, especially some of the changes in some of the runtime behaviors, you encode them as unit tests, and then given these set of inputs against this particular function, this is what you expect, right?
Yeah.
And then now when you're doing unit tests, you're testing it only on a specific set of input and the expected output. Yeah. But then that specific thing that you're testing, your program or your function could it could behave differently on different things.
Yeah,
right?
different things. Yeah.
So how do you capture that? And that when they do behave differently, that's where your edge cases are. That's where your potential bugs are. So one thing to do could be, okay, fine, maybe what if I can test a large range of inputs, right? And then if I do test the large range of inputs, okay, then does anything fail? And that's what your property-based testing or your quick check, where you define a range of values that you're interested in and then test it against, and also define your desired precondition and post conditions.
Yeah.
And based on that, you run your tests. And if something fails, the property-based test kind of, it tell you where it failed, right? And you exactly know the combination of values where where something fails, and that's how you've uncovered the edge case. But that's nearly not enough, right? Because you're still checking within the bounds of what is within the bounds of the range that you've defined.
Yeah.
So formal verification goes one step further, where it gives you mathematical guarantee that when you do unit tests or when you're doing range bounded tests, the guarantee that you get on your code is anecdotal in the sense that it's for every value, it's for the set of inputs and outputs that you have observed and you have tested, right? When you do formal verification, it is for every possible inputs, and you're able to have that as a mathematical theorem. And there are multiple ways to do it. So one is via what? One is via Kani, or where these are SMT solvers where they reduce your constraints into a specific program that you can run against existing SMT solvers, and then they will, for example, like C3 or CADICAL, and they will basically run it on every possible set of inputs for that particular data type, and when it breaks you get to know, or if it doesn't break, then you have the guarantee that for this specific for these specific inputs on this programs, it works, so you have a mathematical guarantee. So what Lean does is that is one way of doing it. The other way of doing it is at the type system level. That's what Lean does. Lean is dependently typed. Okay. So the easiest way to understand this is, for example, in Rust, if you have defined a function and it takes U32s, if you try to send it anything other than U32, the program wouldn't compile, right? So now you take the same idea and extend to any of the preconditions and the post conditions that you want to encode, right? Mm-hmm. Basically, the loose, I'm trying to define it like as simply as possible so that people understand. Imagine you're in your functions itself, you're able to add a precondition on what this type does, not just on the type but also on the value you're accepting, right? Imagine being able to say that this functions only accepts a number between 5 to 10, or being able to say that it only accepts even numbers, right? And then not only that, being able to have in the same function signature, being able to concretely say that it only returns a number that is greater than 5, for example, or it only returns even number, right? For example, if you divide an even number by 2, you have to get an odd number, right? Yeah. So basically being able to encode these type of properties directly in your types, that's what Lean gives you. And this is naturally very useful. And then when the program does compile, you have the guarantee at the compiler level that this is for these given set of inputs, this is exactly how it is going to behave, and you have like mathematical assurance on it. And that's exactly what formal verification is.
Well, I think that makes sense. So it's kind of like stress testing all possible states that a particular, like say, function could have, even adversarially. So it's kind of like if a function claims to only take.
I wouldn't say adversarially, it's more like exhaustively. One is exhaustively, and the other is like correct by construction, because you're refining the definition of what you accept and what you expect to a point where it's exactly what you want. Right?
Exactly.
So the one you use is mostly based on Lean, right? Like the framework you built.
Sorry? Berlin, can you, I'm having trouble hearing you.
Yeah, I'm saying like the framework you build is mostly based on Lean, right?
Yeah. You mean QED Gen?
Yeah.
QED Gen there are multiple components to QED Gen, right? Like the reason why I built QED Gen was because, with the way AI is kind of taking off, every single developer is using AI to build, right? And even non-developers are using AI to build. And given how AI works, the primary way you interface with AI is via an intent, right? Like you describe it in a prompt. You describe in plain English what you want to do. Oftentimes, the language itself is not normative, right? Like you can't be. There is so much amount of ambiguity in English itself as a language. Now you're kind of putting the load of capturing what exactly you meant onto the LLM so that it understands it and then it produces the output that you wanted. So the room for the LLM to make a mistake is pretty large. So how do you provide guarantees that the LLM went from your intent to the actual model and program correctly, exactly as you intended? And the way to guarantee that is if your specifications and intent is part of the code itself, right? And that's the reason why I started building QED Gen. So QED Gen has a DSL called QED spec, where the QED spec kind of sits in between multiple formats, between Rust, between Kani in Rust, and also between your prompt and lean. So in between you capture how you want your program to behave, the kind of invariance it should hold.
Okay.
So to answer your question, it's like it's not just lean; it also does Kani and a whole bunch of other things.
No, but it's also like specific to helping LLMs not make mistake or to be sure about your intent.
Yeah.
I think previously I took it more as a formal verification tool rather than one that's more integrated with like LLMs. That makes sense. So like I'm pretty interested in like where you see developers using your tool in their process, like moving forward, since everyone is using like LLMs more often. Like, where do you expect them, or you think would be safer for them to integrate it into their process?
Yeah, great question. So today you can use QED Gen in both cases, like in brownfield projects where you've already built it and then you want to, for example, you want to run a quick audit. There is an auditor sub-agent that will adversarially probe against your code and actually discharge first tests, etc., to first find the bugs that are in your program, and then you start defining specs in QED specs so that you can start formally verifying your existing program. That is for programs that already exist. For greenfield programs, it's a lot more interesting, right? Because now you can just start describing in plain English what you want to do, and then it first captures this in the QED spec specification. And once you have it in the DSL, think of this as, earlier we used to go from Anchor or if you're writing in Pinocchio, you would then annotate Kodama and generate ideal. It is kind of it's the inverse. So you use the LLM to define the QED spec. The QED spec is like a superset of what is in your ideal, and also specific invariants on how you expect the program to behave and the handlers to behave, right? So once you've defined it and using your prompts, once you've generated the specification, then you have a QED Gen, right? The QED Gen mechanically generates the code for everything, like your Anchor project, your Quasar project, or even if you want to write it in Pinocchio, it sets up the skeleton, it sets up the function signatures. So the task of the LLM becomes like much more simpler. Now it just has to kind of fill in the boxes, right? You're no longer letting the LLM just design the project and its structure and skeleton by itself. Instead, you're taking the approach where I want this to be architected in a manner where I strictly define what the boundaries are, what the skeleton is. Once you have done it, you're pinpointing the LLM to specific points where it will fill it. And by virtue of doing that, you have the ability to tightly control the code that the LLM generates, and also to ensure that the code it generated also meets the specification that you set out, right? And the fact that you can generate like both Kani and Lean means that you can also formally verify these things. That is one. The other interesting aspect of being able to do it at the project development stage is that you would much rather discover bugs or unsoundness in your own model, or unsoundness in specific math implementation that you're doing for DeFi or maybe for cryptography. You would much rather discover that at the development time itself while you're defining your specification versus you discovering it after you've built the project and via an audit.
Yeah, I'm curious. Like, I have a question. I don't know if you can answer this, but I'm sure you must have used the QED Gen to on actual projects. So I don't know if you could tell us okay, some specific problems that were found after you used it, and okay, you discovered them, and how the flow was, like things that possibly an audit wouldn't have discovered that is discovered, or
yeah. So there are two examples that I can give of projects that I've used, where I have used where they have used QED Gen or I have used QED Gen on them, and I have tweeted about this. So I'm happy to. These are already public, so I'm happy to discuss them. The audit rate team, they used the QED Gen auditor to audit, and it found more bugs than what. It found, I think, 4 bugs. 2 the team had already discovered by auditing it manually, they had known it. And the other 2 were novel findings that QED Gen surfaced for them, which they went ahead and fixed. The other is, responsible disclosure on the rewards program. Solana Foundation has the rewards. It's not deployed yet, so it found the bugs were found and responsibly disclosed well ahead. So yeah, I would highly encourage you to try out at least the auditor sub agent on any of your programs. It should work on 3 of the most popular programming frameworks: Anchor, Quasar, and Pinocchio. It should work on all 3 of them.
That's pretty amazing.
Yeah.
Most people know that okay, the tool is mostly for programs. FX, you were saying something about it was used on Glow. So I'm not really aware of the possibility of it being used for bigger systems.
It's so during I think the Alpenglow I had put up a bounty because it was this was last year, just when I myself was getting into formal verification. I hadn't yet built QED Gen. So there are 2 things to verify it. For example, in a protocol, one is making sure, one is model checking, and one is to actually ensure that the implementation of your protocol meets whatever specifications that you have, right? So that specific bounty when I had put out last year was to just discover new people who are into formal verification, who are into distributed systems, but also have the ability to execute them a little bit deeply. And for example, in Rust there is this library called StateWrite, which is popular to implement systems and also at the same time verify them. I was looking for someone who would implement Alpenglow and also to verify them. And that's the reason we had put out the bounty. But then I don't think it was okay. It was a good experience. I don't think we found many interesting submissions from it. So today, and to answer your other question, today as QED Gen is designed for programs, not for systems. But if you want to do that, then the way to do that would be to integrate QED Gen into something like StateWrite, so that now you also have the ability to define what this complex system should do.
I typically would like to think about aspects where things can fail. So far we've talked about how great this is. Are there known limits besides the fact that with bigger systems it can't do as well as with smaller systems like programs? Are there other known limits that you've come across and the possible solutions to fixing them?
I think, one of the understated fact here is that formal verification is not a silver bullet. It's only as good as what you specify and what you're verifying against, right? So it is kind of the same as in your unit test, right? You take the most simplest case and then that's what you're testing against, and you're not testing anything. Then of course you're bound to have, you will have errors that you wouldn't have encountered. Similarly with formal verification, if your specifications are trivial in the sense that it's very trivial to prove them, and it doesn't really cover the entire breadth of what every path that you do, right? So it can of course catastrophically fail when you do not have good specifications. That is number 1. Number two is that there is a gap between what the model of your program or whatever that that you're defined and what goes into the implementation, right? Like for example, it's the same as for in your design document, you have a specific specification, and then when it goes into implementation, it's implemented in a completely different way. So that gap also could exist. The way to ensure that you do not have any of those gaps is actually this is where lean is so exciting, because both your model and the implementation can live in the same project, and then they can share types. So when you build when you build it successfully, when it compiles, you have the guarantee that as long as it is within the specification, your implementation is also correct.
Okay.
I think
That is one. The other is also, what is your assumed trusted compute base, right? For example, if you're making an assumption about something that you do not have control over, or even if you do have control over, you're expecting something that is below you to work as expected,
yeah.
then and then it doesn't work as expected, then the formal verification cannot save you, right? And or you have like wrong assumptions to begin with, and you encode that into your model.
I feel like that is very interesting, because now I have to ask, like, based on what you just said, like where exactly the trust boundary is, for QED Gen, like where exactly the trust boundary is, because so a QED Gen verified program is, you said that a QED Gen verified program is only as sound as your assumptions below. How do you like communicate the scope limits to users who see, like, okay, because when they come to QED Gen, they are like looking for proofs and like not promises. So like exactly, so like it's like, how do you communicate that to the final users? Exactly, because now I'm just learning that you take assumptions below. So like, how do you manage the trust bound?
Yeah, so I think it's by painstakingly working through every piece of the stack, right? For example, let's say if your project is in Rust and it's in a framework, you assume that the framework is sound, and on top of that, you also assume the compiler is sound. This is all the more important because in Solana we have the platform tools contains forked Rust C and forked LLVM, so you don't know what kind of divergence it has from upstream, right? So that's definitely a trust boundary. One way to speedrun all of that and eliminate that is to directly operate on the bytecode, and that's the reason why I started building QED SVM, which is a lean implementation of SVM. So what this allows you to do is to execute the actual compiled bytecode inside of lean, and also have specifications on what you expect each one of your handlers to do, right? And then what it allows you to do is it allows you to start building the invariants that you expect between how you want your program to behave and how it is actually executed in the bytecode. You can construct those as refinement theorems. So that gives you a level of it gives you a deeper level of guarantee. That is number one. Number two is also at the CPI boundaries, right? For example, if your program is CPIing into something that you assume to work as expected, so there maybe it's a reasonable assumption to treat those as axioms where you expect, okay, fine, I'm going to assume that this specific CPI that I'm going to make on this input will behave a certain way, and you assume that there exists a proof for it, or you assume that to be a universal truth, and you move on. Or in the absence of that, if it happens to be also formally verified and you have a proof for it, then you just compose those proofs.
Okay, so like, I guess my next question is, like, has any auditor attempted to break a QED Gen verified program before? Like, have they just tried to just like break it apart just to see how robust it is?
I'm not sure if other auditors have tried it, but
okay.
it is, as I am building it, it's like I do it myself, and it's open source. People do keep submitting bug reports or sending pull requests, right?
I'm gonna definitely try it out, because like it seems like a very cool thing. It's like a very cool project. I'm not really conversant. This is the first time I'm actually interacting with it, and it's an opportunity because I get to hear from the horse's mouth what exactly it is. So it's like, hey, an instruction manual from the instructor, so like
Yeah, I think the best way to get started is to just, if you have an existing program,
yeah,
you know, just run the auditor sub-agent. It will earn its keep by finding a few bugs that you have missed, right? And then once it identifies bugs for you, and then okay, now you're kind of, it has generated enough interest for you to commit more to the tool chain, right? And then you start, okay, now let me start actually getting into the specification. Let me start getting into the, defining these invariants. Maybe let me generate some of the cunning proofs, right? And then once you feel you're confident with it, okay, fine, let me go all the way to lean.
Okay, I guess that makes sense. Okay, I guess, I don't know, Perlin, do you have any other extra questions? I think I'm already done. I have a very good overview of where I think, like, what I think about the project. I'm definitely going to be trying it out, Shek. So, like, I'm gonna shoot you some DMs about, like, what I think, just to give you, like,
Yeah, go for it. Yeah, and I also, of course, this is like side project for me. I'm spending as much time I have available at my hand on this, and the fact that today you have Fable 5 and Opus 4.8 exists means that
I had
there's a lot more. It creates like new bandwidth for you. So QED Gen wouldn't have been possible without
I
those
heard
tools.
Fable was back. I don't know if it
Yeah,
is, but I was saying
it is
yes,
back.
back.
It is back. So do try it out. If something is broken, the the GitHub issues or better yet PRs are absolutely welcome. I respond pretty fast to both issues and PRs.
Okay, yeah, that's cool. Yeah, so I think that's all for me from formal verification. I already have a very good idea.
Yeah, I think
Okay.
we've touched like formal verification a lot. I think let's talk more about the whole startup side, super team, super team black. Like, yeah, you want to go first on that, FX?
I think I would like to like trim down on the question and just like ask him, what are you mainly focusing on? Because like you said, QD Gen was kind of like a side project. Are
Yeah.
you?
So majority of my time is into Superteam Black. So
Okay.
Superteam Black is Super Team's founder success program, where
Okay.
we work with post seed startups and pre-series A startups in helping them. So
I haven't heard of Superteam Black. Is it global?
yeah, Superteam Black is global. Think of it like Superteam historically has been like exceptionally good and nurturing talent and kind of helping them be a launch pad.
Yeah.
Be it in terms of like finding jobs or getting noticed in the ecosystem, winning hackathons, or even with with accelerators like Coliseum or Alliance. Right now, what happens after the teams get into that program? It's like we are at a point where there's a good amount of super teams that are post accelerator stage.
Yeah.
So it made sense for us to have like a very structured program to. I mean, it made sense to have like a super team dedicated to serving this specific type of teams.
Yeah. I guess that makes sense.
So
Interesting.
it's almost like super teams individually are more organized, they can take care of themselves, and you guys are looking into this new small set of people that okay, we need to go further. So
Yeah.
I'm interested in like I'm sure there has been like new challenges you guys have encountered from just the days of okay starting super team up.
Stepping to a new chapter, like, you're now looking at people that are more experienced. So, what are the challenges that you guys face? Like from the regular super teams where it was more individualistic to the big guys now post seed. Definitely has to be some challenges because these are stakes involved.
Yeah, these challenges are like Super Team Black itself is a startup where we are figuring it out as we go, and our challenges are not really different from other startups' challenges, right? And at the end, we want them to win.
Yeah.
So, and that means that each startup has like, we work with 50 different teams over the course of the year, and right now we are working with 26 different teams. So each startup has its own unique challenges, right?
Yeah.
So it's like each one of them is on their path to PMF, and the fundamental problem comes down to, okay, how do we extend our runway? How do we think about our product? How do we get distribution? How do we, these are very very specific areas where maybe we need help in. Who are the mentors that we could reach out to, right? So we have structured Superteam Black around these things.
Okay. So, I guess for my personal question, like, I'm trying to get an idea of what, like, what the model for Super Team Black is. Is it going to be like, I don't want to say an accelerator because accelerator is pre-seed, but like is it kind of like Y Combinator but for like post-seed company where you guys just like incubate and nurture, like,
Yeah, so we are neither an accelerator nor an incubator.
okay,
Think of this as like white glove operators across tech product and business who work with teams directly in helping them with whatever they need. So it's very bespoke to the team that we work with because everyone has unique needs, and that's
yeah,
the one. And given the nature of it, they're already at a point where they're they're an established startup, right? Like they've raised funding. Now you want to go from a place where you've raised funding to actually dominating that or making a meaningful mark in your market, and that is not. In a way, each one of them is like charting their own path, and each one of that is unique. So then it's back to the fundamentals of, okay, it's like how do we help them on these fundamental pillars.
yeah. I guess that makes so much sense, and yeah, it's just like testament to Super Team helping out for every stage, even when for grown-ups now, for like low-key grown-up companies, Super Team is just there, to just help you through your life cycle as a company. Yeah, so like, I think I lost Shek. Is Shek still on?
Yeah, yeah, he is.
Yeah.
Yeah,
Yeah.
he is.
I guess that's all for me. I don't know about Perlin. I really
Yeah,
had a very interesting conversation, learning about especially formal verification.
yeah.
That's something I didn't really have like high level or even low level overview, and I got both from this conversation.
So yeah,
Awesome.
Yeah. So yeah, I guess Perlin, do you want to round up? Are you
yeah.
done?
Yeah, we're mostly done. Shek, do you have anything you want to like say? Any last words? Something you want to like just put out there before we go off?
No, thanks for having me, guys. This has been fun.
Yeah.
Thank you, Shek. Thank you, FX. Like it's been really amazing. Bye.
Thanks, guys. Thanks for having me.
Bye, Shek.
Yeah.